Yeah.
How is going? How was your exam last week's?
Oh,
How was
exams.
everything?
They were fine. Not bad. What's yours?
That's fine. So, how is everything? How is your hometown? How's the weather? Over here, it's kind of rainy.
Uh, yeah, rainy in Afyon is rainy. What's the Istanbul?
It's
How's
kind of
their
rainy
weather?
also. Like getting cold, hot, cold, hot.
Yeah,
Istanbul
yeah,
weather is
same.
not stable.
Yeah.
And
Nowadays, the Olsties are same, I think.
yeah, and also with Ramadan and fasting stuff, like it's too hard.
Yeah. Yeah.
So, hello guys, and welcome to our club. We back
Welcome,
finally
guys.
after like a long time,
Yeah.
and we are going back again, and we are planning for nice stuff and nice activity. Just wait for us and stay close. So let's start our event. Thank you, Mart, for coming,
Okay. See
and
you.
see you
Goodbye.
again. Bye.
See you again. Bye bye.
So yeah, hello guys, and welcome to Developer Student Club, Üsküdar University. I think let me also go back and keep the slides open. So first of all, welcome to our event. Today I'm going to explain Hello World. What I mean exactly, I mean we are going to today we are going to take a look from a computer side. We are going to understand how computer is understanding zero and one, and how exactly it just like keep progressing with it, or exactly like this. So first I would love to start, what is computer science? Actually, I don't know what is computer science. For now, I just like making simulation with you. But during today, we will understand what is like the main reason of computer science and why they create that department or that field. But you may just like it's not the day for sharing any information. But let's make it smaller. What what is the thing that mostly you are using in the background of your life? What I mean now is I'm not explaining computer science. Now I'm just going back and make it simple. It's a simple question for you. What is the thing that you are using mostly in your life? Mostly, like we are using our phones, our computer, because we are computer science, and so our computer, maybe like our devices. But I want to get more deep. What is the things that you're mostly you cannot live without it in your life, especially in this modern life? Simply, it's the electricity. And without electricity, we cannot use our phones. We cannot use any device, anything in our life. But how can we present this electricity? You may even think about it, like for example, we have electricity right now. How we can understand that there is an electricity? Basically, if we have a lamp, like that lamp, and it's right now it's kind of off. It's off lamp. So that means like there is no electricity because the lamp is off. If there was electricity, the lamp should be on. So this is, you might say, this is not a computer science or is related to computer, but this is related to electricity. And by this we can just have another question. What computer means? Computer means an electronic device for storing and processing data by making some calculation. It might be still not understandable for you, but I will make it smaller shortcut. Computer, basically you have data, you are making it input, you are inputting the data, you are inputting the data from this side. Then over here, let's say this is your computer. Then you have an output. anything that could be output. So in our case right now, electricity is the input, and over here this is our lamp, and output is the lamp is if the lamp is on or off, if your computer is on or off. So you might stay again like, what is this? So I will try to get more simple way to you. And as human being, we invested a method of counting, and started by this. We start to count by our hands any number, because computer, as I just said, computer is counting. I just say like by calculation. So let me, yes, do it over here. So as a human, we start to count anything by like our hands, like 1, 2, 3, 4, 5, and keep going with our hand. The second one, 6, 7, 8, 9, 10. So basically, we are counting until 10, and which called a decimal number, or it's natural number. So let's go back to our code. Okay, sorry. So so as a human, we are just counting from 1 to 10 by our hands. We just started, then we just make a more bigger number. So now let's get a little bit deeper. So if I have this number, 123, how we understand this number, it called 123. Why we didn't say it is 1, 2, 3? How we did it? If you go back to your first school, you will learn that there is like one element, 1th element, and 10th element, and 1000 element. By saying this, we have like 100 times 1 plus 2, 10 times 2 plus 1 times 3. So we are just combining these numbers together to have 100 plus 20 plus 3, that we have 123. So again, we are just, as a human, we are just using 10 from 1 to 10. This is the basic number from 1 to 10. So shortly, this is how we count and calculate the numbers as a human. But still, computer cannot understand this, and computer cannot count like us. Exactly. So let's go back to the same method that we was showing, 123, but this time I will make it 0, and we will start to count, and looks like you have a kid, and you start to teach to this kid how to count. So we are going 1, 2, 3, 4, 5, 6, 7, 8, 9. And by just some magic, when we want to say 10, we just go to next element. So what happened over here? Our fingers, like we can count 10, but as numbers, each finger, it's kind of having just one number. Here is 1, 2, 3, 4, 5. So it's just having one number, one, let's say, digit, one number. But so that's why we over here we showed 10 as two numbers, one in the 10th element and 0 in the 1st element. So that means 100 times 0 plus 10 times 1 plus 1 times 0, which means 0 plus 10 plus 1, which means 10. So going back again from the human being counting style or digital numbers, this is how we are count, and this is how we are our numbers. But again, computer can, as I said, computer cannot understand these numbers, and computer cannot have two numbers in the same hand, or the same finger in our case. So that's why computer is counting with a different way, which is whole numbers. We call it as whole numbers. This is in calculus. No, it's not related to any computer stuff. So its whole numbers is this looks like exactly the same as the digital numbers or the natural numbers, but we just add a 0 in the beginning. But as you saw from the poster, we just use 0 and 1, and computer can count, of course, from 0, because just one number in each one. But after we going further than 9, there will be a problem. So computer is not using this whole number style. Computer is using just 1 and 0. And basically for us, 0 is meaning nothing. 1 is meaning like something, just one something. So we can combine this by our first example about the electricity, and saying that 0 is like off lamp, like we don't have anything, like there is no electricity, and 1 is like on lamp. So we have like our lamp is on, or there is electricity. And so let's combine this one also, this this idea right now, with our last math calculation. So this is our last math calculation, like we say, like 1 and 10th and 1000 element with our lamp. So it will be like this: we have a lamp, we have 2 lamps, we have 3 lamps, and like this lamp is on. So if we just want to present 2, we will just present 2 lamps. If we want to present 1, we will present 1 lamp. But computer doesn't have a lamp inside of it. So computer, if we go back over here and try to make it more easier to understand this calculation, or try to make it more simple to just understand, we say as a human we can count from 1 to 10. So if we just want to make a simple way of this calculation, or these numbers 1 to 10, we can just go for 10 times power of 0. And just a note, any number power of 0, it just 1, means 1. So here 10 power of 0, which is 1, 10 power, sorry, 10 power of 1 is 10, 10 power of 2 is 100. So this is exactly the same as this one, but we just make it in different way. And we just said computer is just have two numbers, 0 and 1, so it just 2. So if we just take this 10 outside and put 2, so we have 2 power of 0, 2 power of 1, 2 power of 2, keep going like this. So basically this means like 1, 2 power of 1 is 2, 2 power of 2 is 4, and 2 power of 3 2 power of 3 is what is it, 8, I think. Anyway, so if we start to count in binary system, we before we was counting 1 2 3, but here it will looks different. And again, this is 1 to 4 is just coming from 2 power of 0, 2 power of 1, 2 power of 2. So if we start, this is 1, this is 2. There's something happened. What happened is, over here we just have 1, so this is 1 number by 1, it's 1. This is our math, math calculation way. 1 times 1, 1. So here we have a difference. We here just 2 times 1 is 2, 0 times 1 is 0, then 0 plus 1, 0 plus 2 is 2. Okay, so then we keep going. This is 3, and this is 4. This is, if we just make it simple, 4 times by 1, 2 times 0, 1 times 0. So this is 4, because we just keep this element, and the others we just like make them 0, so we will not count them. Then this is 5, this is 6, and this is 7. But as you see, all our elements are full right now. We can, if we want to count 7, if we want to count 7, or I mean, sorry, if we want to count 8, we need an extra place. We need to have like one more place, because we cannot count 8 right now. That's why we need an extra column to be able to count 8, because it's more than this three digits. And we call this column as a bit. Bit basically contains either 0 or 1. So 1 bit, it means it's either 0 or 1, just like one number. In binary, or in computer, we call it as a bit. So it means that we have a light, or the lamp. So 1 bit means 1 lamp. And if we have 8 lamps, that means we have 8 bits, which is called as a byte. This is a bigger number, something like 100 and 1,000. So this is something similar to it. We have a bit and we have a byte. Bit is 1, byte is 7 or 8. Wait. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. Sorry. So this byte is just an 8 bits, or it count 8 number. So if we put 8 zeros in front of us, so we will have 2 until from 2 power of 0, like 1, until 2 power of 7, which is 128. So we can store a huge amount of numbers inside of it. I don't remember exactly how much it was. So if we followed all of it with the numbers, we can. I think it will present a lot of things. So again, let's go back to our normal computer. Wait a minute. Okay. So this is our normal English. This is the normal English keyboard, and I think none of the devices that it doesn't have this keyboard. So if you want to write something in your computer, like a letter or something, you will go by writing it on any documentation file or text editor or Word or etc. So if you write A in the screen, like it is it's just an A for you, but what is that? What does it that means exactly for computer? Um, exactly by ISKI number. ISKI is American Standard Code for Information Interchange. It's like a system that is just presenting how computer can understand the letters. So I will try to explain it in short. As a human, we are giving something a value. For example, this is a mouse, so we just like give it a mouse, give it name as a mouse. There is a pen, other stuff. We just name it. So for computer can just, as we just say, we just 0 and 1. So how we can store 0 and 1 and like give it like a letter or give it a name. So by ISKI system, they provide each letter has its own number. So if I want to say E, I will say to computer 69. If I want to say F, I will say 70. Like this. And ISKI, there is a lot of a big table of ISKI numbers, and each letter presents a number. Even 0 is presenting something like null. So again, go back to our A letter that we wrote it in the docs file. And from ISKI number over here, 8, A means 65. So if we want to show 65 in coding, we will have this number in binary, sorry. If we want to show it in binary, we will have this number. This is exactly 2 power of 0, 2 power 1, 2, 3, you get it, I think. So if we just take this one until 1 to 128, we will have 64 plus 1. The others are 0. We will not count them. We just count the column that it has 1, the bit that it is on. The others off, we will not count them. So 64 plus 1 is 65. So this 65 is presenting a letter in the screen. So if we just go back to our first coding explanation, that the box one, and try to put all this progress inside of it, we will have like input is typing on your keyboard. You just type in the keyboard a letter, then it just transforms to electricity by some electric circuit and transaction help. Then it just transforms to binary because like inside the electricity because the electric circle and transactions help just go to binary like 0 1, like on off. Then it just take it as 0 1 by CPU, and inside the CPU it just transferring to ISKI, and ISKI just transferring to letter. Then it just show it to you on your screen. Show it to you like this on the screen, but this is just a one letter. What about if you're writing a paragraph or you are writing an essay? What will happen? You are going to read. Are you going to like? Are your computer going to read like 0 1 1 1 1 0 1 0 1 1 1. It looks like a rap song, or it will looks like this. So again, if we go back, I will show we have this number 72, 73, 33, and this numbers. If we look at ISKI, we will have 72 is H and 73 is I. Then we have 33 is explanation mark, which means high. So if we take it 72 and 73 and 33 in binary, we will have like 0 1 0 0 thousand and keep going. So this is about how computer can understand the letters. But I think you may have a question in your mind how computer can understand the emojis. Wait a minute. Okay. So basically, emoji are not in ISKI unit or ISKI system. They are in something called Unicode system. This is that which is has more digital, not more than not more than 1 byte. So like maybe 2 bytes or more. I don't remember exactly. So that it contains our emoji. But again, emoji it's not a letter. It cannot be a letter, but it's kind of a photo. So how our computer can understand this photo. So if we go deeper, more deeper, more deeper, more deeper, you start to see like there is a pixeling, we call it as pixeling, or like this smaller circle, circle, rectangle, I think, this smaller rectangle over here, which called a pixel, and it just like we just take one of these pixels, which is this one, let's say, and it's yellow. It's yellow one. Sorry. So by Unicode, this smaller yellow color is just presenting this number, which is 128,540, which is mean this number. It's too big. I will not read it. Which is just presenting just one part of this emoji. So just this color, just one color have contain this number that presenting this one. So what about this color? How we just have this color in our screen? We have RGB system, which I think you may ever see in your photo, like this is dot RGB or GB BNG or something like this. So I'm going to explain what is RGB. RGB basically is just three letters from this: red, green, blue. So if I want to show up the yellow one, I need to set three of them. So if we go back to 72, 73, 33, which was high, and we just use exactly the same in RGB, so we have 73, 72, 73, 33. So that means I'm saying use 72% of the red, 73% of the green, and 33% from the blue, which will give us this color. So this is just this is just one pixel of this picture again. So I think what about the video? Video is not just it's not a photo. It's like a serial of photos. And to understand more about the video, how video is working, this is a short video about how exactly it works. Okay, so let's have 10 minutes break and we will go back. Don't go anywhere. Our break, I will announce something for you. So then we go back to after 10 minutes we will back. So let me just go back. Where is it? Okay, anyway. So in our wait, it doesn't want to work. Okay. So in our club, we are announcing a new leadership. Then the developer student club program. It's announcing a new leadership, and for the next year. And I'm inviting all of you, if you want to be the next leader of this club, please sign up for the link that I will share it with you. And yes, over here, so you can just join the leading program from this link. And as well as I will share with you a video about the DSC leader program. And thank you, and have a nice break.
Google Developer Student Clubs train hundreds of thousands of university student developers globally while having fun getting to know other students at their school. Google selects students with strong leadership skills from across the globe once a year to start a club on their campus. These leads believe knowledge is power and that technology can do extraordinary things for the world. They take on the responsibility to help students learn and empower each other to solve real problems around them. Students can participate in the annual Solution Challenge by Google developers to solve for one of the United Nations Sustainable Development Goals. Join us in building a global community for students in technology.
Çok güzel başladı, çok sıcak başladı. İnsanlar birbirleriyle tanışıyor, konuşuyor, sorunlarını birlikte çözebiliyorlar. Kendi illerinde, üniversitelerinde yaşadıkları sorunları.
Buraya gelmek bir kere muhteşem hissettirdi bana. Yurt dışındaki bir Googler'ın burada gelip bize bilgiyi birebir aktarması benim için muazzam oldu.
Uluslararası Google'larla tanışma hem de bizim yaptığımız çalışmaların uluslararası bağlamda diğer üniversitelerle kıyaslanması ve ileriki aşamaları görmemizi sağladı.
Şimdiye kadar diğer liderlerle hep biz internet üzerinden konuşmuştuk. Diğerlerinin yaptıklarının hep fotoğraflarını falan görmüştük. Yüz yüze konuşma fırsatı bulamamıştık.
Bu kadar insanla bir araya gelmek, hani yüz yüze konuşmak, onlarla aynı duyguları paylaşmak çok güzel bir şey.
Google teknolojileri konuşuyoruz. Bilmediğimiz şeyleri öğreniyoruz. Bildiğimiz şeyleri paylaşıyoruz. Ve hepimizin birbiriyle tanışıp kaynaşması için mükemmel bir etkinlik oldu.
Привет. Hello. Servus.
Marhaba.
Hola.
Hello.
I'm inspired that there's so many people working to accomplish the same goal of creating a connected future.
By having students lead clubs on campus directly supported by Google developers, that's the best way to reach out to students.
It's really inspirational always to hear about members of the community who echo your values and echo your beliefs.
I've been listening more than I've been speaking, and I don't necessarily think that's a bad thing because I'm just getting all these ideas.
Google, it needs to reach a wider audience and be more relatable as a company, and I think Google is one of the brands that is very good at doing that.
All right. So before going back, I would love to just see again. Developer Studying Club. A program is program based, powered from Google. We are trying to make events for the students in our campus to help them. Wait, I forget. To help them to make better career life, let's say, and also make them like develop theirself in coding and programming stuff, and also in Google technology with help of Google technology. And if you want to be the next leader of your campus in Üsküdar University or maybe another university, just hit the link. Let me share it again. So just hit the link, and the application will over in May, I think. So don't waste your time. If you see that you might be a great leader, just go on and subscribe or just fill the form. So let's go back to our event. Let's go back to our. So where did we live? We live on. Okay, you just say we live on Hello World. So I just explained to you exactly what is Hello World, how Hello World come up. So Hello World is just a letters that is coming from your computer in the backside, which each letter of them is presenting by a specific number using ASCII unit, and this ASCII unit is just transformation from the CPU that show you up these letters from your typing on your keyboard. So all of this things just happen inside of our box. So I think this is time to give this box a name. And some people don't like this name, especially who is studying software or computer engineering, which is algorithm. So basically, we have input. Then we have inside this box we have the algorithm that give us the output. So everything is exactly looks like this. You're typing something, there is algorithm kind of like ASCII unit or etc. And it's just getting outside the input to your screen by showing you the letter, by opening a new page or closing the page, etc. So what does algorithm means? Algorithm, it just okay, there is nothing here. So algorithm is just like a set of rules or set of actions that you are taking to achieve your goal. So we will, let's say you are going to your house. So you are in the front, you are in the street, like in outside the street. So you know how to go to house. You are just going straight, right, left, right, left, then a little bit forward, then you are arrived to your house. So this is exactly what is algorithm. Algorithm is just like actions, set of actions or list of action. You just like one by one, going one by one until you achieve your goal, and you get like the output. So, but how can we use the algorithm? Maybe the example that I gave to you, and there is another example which is phone book. I don't know if you know phone book or not, but you may ask like older people. So let me just make the screen bigger because we will have some actions. So phone box basically is just like a big book, big book that it is it's including a number of the people that are around you, or maybe some people that you doesn't know, maybe like some electricity company or gas company or water company, etc. So let's say I have my friend Samet Mart, and this is his number, and I just want to call him. Do not try to call this number, okay? So I want to call him. So phone book, if you don't know, it's like a big one, and there is. Okay, let me back to screen. I love to go back again. So it's a big one, and there is like a lot of letters. So if you just go one by one, it will look like this. Let me play the video. So it will just look like this. You're just going. So basically, you are just going letter by letter, and after a while, you're still going. Like it just this expression, it will take like a time to do, but let's be smarter. Even if you are smarter and you just like go two letter by two letters, two pages, sorry, two pages, but two pages, it will still take a progress. Yes, it's faster. This is also an algorithm. This is also working, but it's still, I think, still there is more some way faster. And if we was in the campus, I would love to like make a physical example, but unfortunately, because of the pandemic, we cannot. So we're just using a YouTube videos. So I think this one, okay. So in this example, what is going on? I just like dividing the book or dividing this book by into like pieces. So like I'm just opening from the middle, cut. If it's not summit, cut. If it's summit is not that side, cut. So basically, basically I'm just opening the book from the middle over here, and because of this book is just like sorted by letters. So if S letter is not in the right part, cut it. If S letter is not in the left part, cut it, and just open it sorry. If the S letter is not in the right part, cut it. If S letter in the left part, open the left part again from the middle and look if it's right or left. And cut the part that S letter is not over there. And do it again and again and again. And this way, as you can see from the video, it's just faster. The last video, it was like about 6 minutes. Over here, it's just like 10 seconds. So it's such a way faster. So this algorithm, we can just explain it by pseudocode. Pseudocode, it's not a coding. It's not something like you can code, but it's just like a way to explain the algorithm that you are making in set of actions and set of values. I will explain a bit of it. So if we want to come back again and start to say the last thing that we did, cutting the book from the middle, and just like set everything that we did again. So we will say pick up the phone book, then open the middle part of the phone book. Okay, sorry. Wait, what happened? Okay. So then look at the page. And if summit in the page, call Ahmed. Allah shukr. We just found the summit. Ahmed, like our friend, let's say. Then else, if summit is not area in the book, I mean, like let's say the right part or area in the book, open the middle part of the left half of the book. Do it again. Do it again means go back to the first step that we start and do it again. Look at the page. So I'm just like starting all the steps again. If it's not in the right part, so I'm just go to the left part and look at again. So I'm doing the same thing again for the left part. Just opening from the middle and look at it if it's right or left. So, but if it was not in that part, so I'm just looking if summit in the luster in book, then I'm opening from the right of. So I'm opening the middle of right half of the book. So the right half, I'm just opening in the middle of it and take a look again. And I'm doing it again. I'm doing this expression again. So after doing this, I kind of like dividing the book by half. Then which half is over there? So I'm dividing again by half, again and again, until we find Ahmed. But if it's not here, we just quit. Like there is nothing to do. Summit is not in the phone book. So if we just take a deeper look on what exactly we did, we will have pick up, open to, look at, call, open to, quit. So this is kind of action, like do this action. Pick up the phone book, open to the middle part, look at this page. So this is like action. You are doing some of actions. And if we just take another look, we have F, else F, and do, and else. So this is called algorithm. So both of them, algorithm is taking action and do some decision. So over here, I just like, if this over here, I'm taking this decision. If summit on the page, that means it's just, he's on the page, so it's done. But if it's not, so this is like a decision. You are taking a decision, and at the same time, you are taking action. So both of them, this is the simple way to explain algorithm. So what about programming? Programming is shortly looks like that example. Let me go back. It looks shortly like that example, but just in a different way. And I think you hear about programming language. So each programming language, it's do something specific task, something like ASCII task and Unicode unit. Each one of them is doing something special. ASCII unit is just for letters. Unicode is for emoji or bigger sized letters, let's say. Not letters, but like emoji or maybe image, etc. So it's like something bigger than just a letter. So also programming language is something similar. We have some programming language for different stuff. So what can we do exactly with programming language? Exactly, there's a platforms. We can just make it shorter. This is development platforms. So there is a lot of platforms that serving you in different ways that all of them are serving exactly the same box that we have at first: input, then we have the algorithm, then output. So in algorithm, it's just like the programming language. And again, programming language, if I didn't explain it clearly, programming language is just a language that explained to the computer by looks like pseudocode that we just show you what computer will do, and it just transfer this stuff to ASCII or etc. and just transfer to CPU. So it's kind of like low level language, like kind of like you're talking with a kid. So like you're giving a middle age between you and your kid, and trying to like talk with this person, then this person trying to talk with the smaller person, something similar. So let's go back. Platforms, we have many platforms, some of them desktop development, mobile development, web development, and device development, which is like Internet of Things and etc., like artificial intelligence. And there is a lot of examples on the internet. You can just go and search some of them. And each one of them is serving something specific. Mobile is serving for mobiles to have like mobile stuff. Desktop is just for your computer. Web is just for the website. So a network. Internet of Things is just for your refrigerator or your air condition or even your washing machine, or right now your cleaning, almost the new cleaning machine, or for example your light, if you just turn on and off. So this is Internet of Things, and there's more examples. So if we just take web development as an example, inside web development we have front end and back end. And if we just take front end as an example, we have HTML, CSS, JavaScript. They are the programming language that they are serving the web front end development. And for each one there is like more stuff. HTML and CSS and JavaScript, they are not the only languages for serving the web front end. There is more and more stuff. That's why I'm saying you have to search by yourself. So after all of this, I think you should think about what will be your next level, your next step, which platform you are going to use, which how can I say, which platform you are going to use, which people or who will be the person that you will going to serve and going to give him the output of your work and like make his life easier by this work. And I have here a smaller example about Anna. So let's watch it.
It's very special to know that there's something out there millions of miles away that no one knows about except for you. It's kind of like you're given. To make a neural network to help speed up the process. But in 2013, Kepler's reaction wheels broke. So Kepler couldn't stay steady anymore. Can slowly but surely build up their knowledge and discover things that they never thought were possible. If I could do it, I think everyone else can do it.
I'm so sorry for the what happened, but let's play it again. And I think now you can hear the video.
It's very special to know that there's something out there millions of miles away that no one knows about except for you. It's kind of like you're given secrets about the universe, but it's my job to figure out what those secrets mean. I had no idea that machine learning had been used to find planets before that. I've heard of machine learning to find cat faces in YouTube videos and, make memes, but never for like a scientific pursuit. In 2009, NASA launched Kepler Space Telescope, and its goal was to find planets. And it did this by staring up at hundreds of thousands of stars. If something passes in front of one star, you're going to get a decrease in brightness. And so if you get that dip periodically, that can be a sign that there is a planet there. One astronomer can't go through all that data successfully. So Chris and my professor, Andrew Vanderberg, were working on a project to make a neural network to help speed up the process. But in 2013, Kepler's reaction wheels broke. So Kepler couldn't stay steady anymore. The algorithm that Chris made couldn't work very well on that new scrambled data. So I was going to modify this neural network so that we can find all the planets that there are in that data set. I spent, 40 hours a week working on my laptop. I went from knowing nothing about machine learning to training my own model using TensorFlow. My code wasn't working exactly right. For whatever reason, it wasn't learning at all. I was scared that maybe it was all broken and I couldn't find anything. Then I sent Andrew some targets like, do you think these are real? And I got an email back pretty quickly that said, yes, I think these are great. Congratulations, you found your first planet. I remember screenshotting it and sending it to my family group chat. Like, look guys, I am finally I'm a planet hunter. I found planets, this is the best feeling. I knew nothing at the start of my project. A beginner can slowly but surely build up their knowledge and discover things that they never thought were possible. If I could do it, I think everyone else can do it.
Thank you, Anna. So again, so as you say the story, Anna, she doesn't know anything about coding or programming, but she has a dream. And for doing her dream, she just work hard. She like 14 hours for a week, in a week, or I think in a day, I don't remember. But she worked hard on herself. She tried to do everything that she can do to work, and after she like feel disappointed about her work, just like her work is worked, and she find a plant and they just give it her name, and now there is an Anna plant thanks to her, and thanks to her fighting to learn, because this is like a fight. You are just fighting yourself, fighting everything around you because you want to be something. And you may ask yourself, why we are doing all of this, why we have to be a programmer, why we want to be a programmer, why there is a programming language, why there is everything. You may ask a lot of whys to just like know exactly the answer. But I will say in shortly, in my point of view, why. Because right now, just take a look around you. Look at your younger kid in your family, or just the kids when you are having like family meeting or something. Look at what they are doing. They are just sitting down, using their phone, watching a YouTube or playing games. So mostly they are using their devices. Or maybe right now the new babies, you have to give them your phone to be able to be silent. Otherwise, they will just keep crying all the day. And this is a dangerous technology, and as you know, it's a dangerous technology. Is an open place. Anyone and everything can just show up to you. And that's why for kids it's a dangerous. They doesn't know exactly what they can do. They are aware of their feelings, they are aware of their decisions. They must be someone who's just like helping them or leading them. That's why we are here. That's why we are trying to lead the other people around us to learn more about technology, because this is a technology, and if you don't know this technology, that means you are not living in this world right now. That means you are just stuck in the old centuries. You have to know how this technology is working. You have to know what's going on inside your device while you are just typing. You have to know what is going on YouTube while you are opening it or watching a video, the algorithm of YouTube or etc. We have to know all of this information because we want to be better. We want to make this world better. We want to grow up our kids and safe. We want to be something that just like push ourselves into the future with a great life, let's say, or just like, let's say, comfortable life. And I would love to finish my talk about why with a video from Google about
the most human trait is to want to know why. And in a year that tested everyone around the world, why was searched more than ever.
The spread of the coronavirus has passed a significant milestone.
And while we didn't find all the answers, we kept asking. Some questions inspired joy, others excitement.
Life in the bubble.
You love me? Yes. You love me? Yes. You love me? Yes.
I don't know what an improper fraction is.
Keep all of those distractions out of the way.
We found toilet tissue, y'all.
Oh my God.
Put it on there and start it up for me.
What are y'all doing? It's still March. How many days in March?
Some questions made us cry.
You know, we've been through our ups and been through our downs. I think the most important part is that we all stayed together throughout. I love you guys.
Some made us worry about this spinning rock we call home.
Fires were detected in the Amazon rainforest.
Why were so many lives lost?
Almost 1.5 million people have now died of COVID-19 worldwide.
Why are we still asking the same questions?
George Floyd repeatedly told the officers that he could not breathe.
So why do we still have strength to continue?
I believe in your power. I believe in our power.
Chants of Black Lives Matter echoed from thousands of protesters in cities around the world.
Why are we not defeated?
We have made too much progress, and we are not going back. We are going forward.
Planes are starting to arrive in Beirut, full of international aid.
Firefighters from around the world arriving in California.
There are over 100 coronavirus vaccines in development worldwide.
This is one of those times when people look out for one another and have each other's backs.
We kept going for those who showed us the way.
Think about how you would like the world to be for your daughters and granddaughters.
Remember, the struggles along the way are only meant to shape you for your purpose. Press on with pride and press on with purpose.
Why is it that this year showed us its worst and we still found ways to triumph?
An incredible feat for Maya Gabriera.
Naomi Osaka, U.S. Open Championship.
Can't let Corona stop you. Can't let quarantine stop you.
So until we get to every answer, we're still searching.
Yes, thank you guys so much for joining us today. And last thing that I will say, a question: why you are not subscribing to our channel, and why you cannot just go and subscribe for our social media for waiting the next event. Thank you so much for coming.